factoring approach. We'll also look at some special patterns today. So Connor, we have n minus 8, n minus 9. What are you doing to find the product? Yeah, foiling it. So when you foil it, what do you get?
That answer?
Yep.
M squared minus 17m plus 72.
Nice. So that's taking your first, your outer, your inner, your last terms, combining the middle two terms to get that negative 17 out. Questions on 1? Odette, what do you have for number 2 with z plus 20 and z minus 20? Yeah. So with these two, these binomials, that's what they're called when there are two pieces in the parentheses. They're the same, except we have opposite signs. And because of those opposite signs, we end up with a minus 20z and a plus 20z. And because we have that positive and negative sign and the values are the same that we're multiplying, they cancel out. So we don't, instead of combining them together, because they're opposite signs, they actually cancel from the problem. So that middle term is gone. That's why we just have the z squared minus 400. For number 3, we have d plus 9, and then outside there's a square term. What does that mean you're supposed to do with that? Yeah, so it really means there's 2 of that same quantity. So that little 2 doesn't distribute through. It means that that quantity is doubled. It's repeated twice. And then, Gavin, when you FOIL these two together, you end up getting? Good. And then number 4, again, it's that quantity that's squared. So that means there are 2 of them, except it's a minus sign inside. That doesn't make a difference, though. So we have x minus 4 quantity squared, which means there are 2 of them. So Mackenzie Myers, when you multiply x minus 14 times x minus 14, you get?
X squared minus 20x plus 196.
Say it again.
Plus 196.
96, yeah. I thought you said 36 at first. So before we move on to the next question, just looking at the way the problems began, so 1 through 4, those 4 problems, we will be pretty much taking this part here, so we'll be looking at this, and we will be going back to the original problem. So we're going to be doing factoring, which is the opposite of foiling. So foiling means multiply them together to get an equation in standard form. Factoring is taking a problem and placing it or changing it to multiplication. So we'll be doing the opposite today. So our answers will look like quantities in parentheses instead of having something multiplied out. So this is standard form. We'll be taking it into factored form. And other 2 types of problems that are a little different. Number 5 says find the GCF of the following pairs. And in this case, we have 15 and 30. What do you think about if you're finding a GCF? So we have 15 and 30. What does it mean if we're finding a GCF? what does GCF mean?
Greatest common factor.
Greatest common factor. So if we're finding a greatest common factor of 15 and 30, Julia, what did you do this? Think about it.
15.
So it wouldn't, so she said 15. Why would 15 be the greatest common factor?
15 is divisible by 15, and it's even. It's not like that's one.
Right, exactly, yes. So
30 is divisible by 15.
exactly. So you're looking at a number that divides evenly into both of those, and you want the biggest number. So like 5 goes into 15 and 5 goes into 30 evenly. 5 goes into 15 3 times, 5 goes into 30 6 times. So 5 could be an option, but it's not the biggest option. So greatest common factor, you're looking for the greatest number that you could kind of pull out of those, and that would be 15. 15 is the biggest number that would divide into both of them. It can't be more than 15 because 15 is kind of our point there. Anything bigger than 15, then it wouldn't go into 15 because it would be larger than. So you're looking for the biggest number, the greatest factor that would divide into those values. So B just kind of builds on A. So we still have 15x and 30x squared. So the number is the same. And then looking at the x and the x squared, you have to kind of ask yourself, what's the variable that they both have, and what's the largest power that they both could have? So the first one has an x, the second one has an x squared. So what's the largest power that they both have in common? So Julian, what would you say for letter B? Yeah, it's 15x. Because this one only has an x, and it doesn't have more than an x. Yes, the other one has an x squared, but they both only have that x in common. So you can't have more than what's up there. And then for letter C, again, it just builds on letter B and A. So we have 15x squared, y, and then we have 30xy squared. So we know 15, because we're dealing with 15 and 30. And then Emma, what would the variables be that they have in common? xy. So the first one has an x squared, but the second one only has an x. So that means because the second one only has an x, they can only have an x in common. And then the first one has a y, the second one has a y squared. So again, they only have a y in common. You can't have more than what one of them has. So 15xy would be the greatest common factor. So when you're looking at this number cannot be more than what's up there. It can't be more than one of the values that's up there. Any questions? And then the last part kind of talks about a little bit what we were going over prior with the parabolas that we were looking at. A car travels at an average speed of m plus 7 miles per hour. It's kind of weird to think of it as just a variable quantity. And then it says it does that for m plus 2 hours. What distance does it travel? Now, because of a variable, we can't actually find a numerical distance. So we don't know what the distance could be, but we can find an expression to represent the distance, and then we could kind of evaluate it and say, all right, well, what's the max speed or the max distance that we could travel? What's the minimum distance that we could travel? So we can evaluate it using the variable. But how would you find this? So a car travels a speed of m plus 7 miles an hour for m plus 2 hours. Find the distance. How do you find distance? Anybody remember the distance formula? It's a little teeny tiny formula. Joel. Yeah. So distance is equal to speed times time. Sometimes we refer to that as rate. They mean the same thing, how fast you're going. So Joel, in this case, our speed is m plus 7, and the time is m plus 2. So if we FOIL these together, we get an expression that represents distance. So that would be m squared plus 9m plus 14. So I know it kind of doesn't mean anything right now, but we could find the maximum distance that we can travel because we know know how to find that vertex. So we could find the axis of symmetry, we could plug that in for m, and then we could find the maximum distance that we could travel based off of this expression. Or we could find out how far we would travel if the m value was 5 or if the m value is 10. So this would be an expression to represent the distance based off of those two given quantities. Questions? So today we're going to look at a couple of different terms that are down below, and then we're going to start by factoring using the greatest common factor, which would be the previous example. We'll factor using a problem like number 1, and then we'll factor with this 2, 3, and 4. Those are all kind of special patterns. So we're going to do all 3 of those today. A couple examples of each, but underneath we have a couple of terms to look at, like monomial, binomial, trinomial, and then that quadratic equation. So if something is considered a monomial, what is a monomial? So think of the suffix the mon, or is that the prefix? Prefix? They're all called affixes, I think. But what's mon mean? Julian? 1. So a monomial is just one term. So if you have an equation that's a monomial, that means we have y equals 3x squared, y equals 7x squared, y equals 15x squared. So one term, we'll just say 3x squared. So a monomial is one term. That's usually your basic graph, because it's not shifting left, right, up, down. So a monomial is a basic graph. So then a binomial, Maggie, would be 2 terms. And when we factor, our quantity in parentheses will be binomials. They'll have 2 terms in them. So it might look like x plus 7. So we will factor into binomials, 2 pairs of binomials in most cases. All right, the next one we have is a trinomial, so just kind of building on that. Probably a trinomial would be 3 terms. And that's the standard form of the quadratic equation. So we might have something like x squared plus 4x plus 3. 3 terms in it. So that's the standard equation of a parabola, and it has those 3 terms. And then the last one, the quadratic equation, is what we have been working with, that quadratic equation in standard form. Ax squared plus bx plus c. Sometimes you'll see it set equal to 0 so that we can actually solve for x. So if we're solving for x to make it a true equation, because an equation is something you solve for, then it would be set equal to 0. And that'll be our goal tomorrow, to solve for x. So one term monomial is not factorable. A binomial can be factorable, a trinomial can be factorable. And those will be the problems that we're going to look at. So we already talked a little bit about the greatest common factor. Julie, I'm going to go back to you. What did you say the greatest common factor was?
For the last one?
Yeah.
15.
Okay, but how did you explain it? How did you describe it?
There's numbers that multiply together.
Okay,
And
so
they have to be an even number, but it can be decimal.
right.
So we just
So she said you're looking at a number that will divide evenly into 2 values, 3 values. So we'll say the largest number 2 or more terms have in common. And of course it can be a number, but it also can be a variable. But they have to divide in evenly. So for them to have it in common, it has to go into those numbers evenly. So we're going to factor using the greatest common factor. So this would have been like the first way you would talk factor, by pulling out what things have in common. you must always check for the GCF first. So when we're factoring, there's a little checklist that we'll start going through in our mind. And the first thing on the checklist would be, do the values have anything in common? So GCF always gets taken out of every problem before we approach any other type of factoring method. So in these three problems, you now see that they are binomials. So there are two terms here. And we're just going to see if we can factor, which means change it to multiplication. That's what factoring means. Our answer should look like a product. By taking out what those terms have in common. So the first one says 4x plus 8. So Bram, what would 4x and 8 have in common? 4. So the greatest common factor is 4. 4 goes into 4 one time, 4 goes into 8 two times. The first one has an x, the second one doesn't, so they don't have it in common. How would you make this into a factoring problem then? What do you do with that 4? Bram, do you remember? So we need to make it look like multiplication. That's our end result. Go down. So she said you divide the 4 out, and then what is it going to become again? It'll be x plus 2. And that x plus 2 goes in parentheses, because we should be able to distribute the 4 back through and make it 4x plus 8. So factoring means take what you have, pull something out of it. You're trying to make the quantity smaller. So whatever they have in common, we're pulling out, replacing that number in front, but you're really dividing those two terms by that value that you're placing in front. So whatever's in parentheses should be less than what you started with. So it's like a way of reducing or simplifying. So we divided by the 4, it goes outside. Those terms that were divided by 4 go in the parentheses. So 4 and then x plus 2 would be our factored form. So factor means change it to multiplication. You have to keep that 4 there because those expressions are equal to each other. They're just written differently. So letter B is a little more challenging because we have a couple of variables here. So we have 15a squared b cubed plus 20ab. So start like piece by piece. Look at the number. See if you can pull out the GCF of 15 and 20, and then use the variables. Anyone want to take a shot at the GCF? Gavin, what do you think? So GCF with the numbers are 5. 15 and 20 are both divisible by 5. There's nothing larger that can go into them. Gavin, how about the variables? AB. Because that second term has nothing larger than an A and a B. So then you're taking 5AB and you're dividing each of those terms by 5AB. So you're taking it out of the problem. So Gavin, if we take 5AB out of 15A squared B squared, you're left with 3AB squared. So 15 divided by 5 is 3. There are 2 A's, we're taking 1 out, so you have 1 left. There are 3 A's, or 3 B's, you're taking 1 out, so you have 2 left. So you're taking them out, you're placing them in the front, whatever remains goes in parentheses. And then Gavin, the second one would be plus 4. 20 divided by 5 is 4. There was an A, but you got rid of it because you put it in the front. There was a B, but you got rid of it because, again, you placed it in the front. So we have 3A squared, or AB squared, and then plus 4. So factored form, parentheses. You should be able to multiply to go back if you needed to. And then the third one, we have 10xy minus 30x. Abby, what do you think?
The GCF would be 10x.
No y? No, because
The 30x is 10.
yeah, 30x doesn't have a y, it just has an x. So just 10x, and then when we divide by 10x, Abby, you get,
Y minus 3.
yeah, y minus 3. Questions? So just take it piece by piece. Look at the number, look at each different variable, kind of see what they both have in common. So that's the greatest common factor method. like the kind of where you start. Yeah, look at a problem and you say, do they have something in common? If so, you want to pull that out before you try and factor it in any other way. So the second way of factoring would be for trinomials. So now we're looking at the trinomial. It's in that ax squared plus bx plus c form. So we have x squared plus 7x minus 8. So think in your memory bank, and I think I had like 2 questions on that pre-course test that I gave you on the first day of school. Evil Mrs. Kane giving you a pre-test on the first day of school to take home for homework. So if I have a trinomial, how do you try and factor it? Your goal is to have parentheses in the end. That's what your answer should look like if something's factored. So what do you do to try and factor something like this? Like there's a thought process that you need to think about. Honor?
Do you find numbers that combine 7 and multiply to negative 8?
Nice job. So you're looking at the last number here, the negative 8. And he said you're finding numbers that combine together to be 7. So add or subtract to be 7. But multiply to be negative 8. So Connor, what 2 numbers multiply to be negative 8? We'll start with that. So negative 4 and 2 multiply to be negative 8, but do they add to be positive 7? No. How about another pair of numbers that multiply to be negative 8?
8 and negative 1.
Yeah. So 8 and 1 also multiply to be 8. When you have 8 and negative 1, those 2 numbers add together to be 7. So you multiply to be the last number. Whoops. You're trying to add to be that center number. So we're trying to get them to combine to be 7. These 2 are your factors. Our goal now, because it's a trinomial, is to have 2 sets of parentheses. In those parentheses go x, because there's an x squared here, and the only way we can get an x squared is to have an x times an x. And then the 2 factors that you decide on go next to the x. So it's a positive 8 and a negative 7. Sorry, a negative 1. So if you FOILed this to check your work, because FOIL is the opposite of factoring, we would have x times x, which is x squared. We have x times negative 1. We have 8 times x. And then we have 8 times negative 1, which is negative 8. So right here is our negative positive 7x minus 8, and then the x squared. So this is just a little check here. This is the answer. Factored means you should have something in parentheses. Here's our check step to kind of make sure that it worked. So the reason the x's are in the front is because we have to get that x squared to be in the front of the problem, and an x times an x is how you get that. So why don't you try the second one? So look at letter B. You're trying to get 2 numbers that multiply together to be negative 10, but add to be negative 3. So multiply to be the last number, add to be the number in the middle. You can always check your work. No, you don't have to, but you always can do a mental check to make sure you factored it correctly. Emma, what 2 numbers multiply to be negative 10? So negative 5 and 2. Negative 5 plus 2 does make negative 3. So once you figure out your factors and they combine to be the correct value in the middle, place those factors in parentheses, x minus 5, x plus 2. Or maybe you have x plus 2 and then x minus 5. That's the same exact thing. Just depends how you list your factors, how you think of them. And then number 3, Rebecca, what 2 numbers multiply to be 16, but add to be 10? 8 and 2, both positive? So then, positive 8, positive 2. Or positive 2 and then positive 8. Questions? you can do a quick mental check because we have x squared, here's a 2x and an 8x, so that gives us positive 10, and then 8 times 2 is 16. So a little mental check to make sure that the two terms that you pick do FOIL out to be your solution. Questions? So that would be factoring with ax squared plus bx plus c. And this is just when the coefficient, the number in front is a 1. It does change once that number changes. Right now, all the problems we're working with would have a number in front of a 1, just an x squared there. So the last type, and I said we had 3 different types to work with, would be factoring using special patterns. That means that the numbers in the problem have something in common. They have a special piece to them. And the type that we're going to look at, there are 2 different types. The first form, or pattern. This is almost like having a little formula to follow, or a rule to follow, is a squared minus b squared. So if you look at the 3 numbers up here, just the numbers, the -4, the -36, the 64, and actually just look at the values, 4, 6, 36, 64. What's special about 4, 36, 64? They're special numbers. Why are they special, Holly? Yeah, they're all perfect squares. So 4, 36, 64, those are perfect squares. So when your numbers are perfect squares, there's a special pattern that you can use to factor them. So this is factoring with perfect squares. And the pattern says if your first term is squared, that's what a squared means, and your second term is squared, that's what the b squared means, and there's a minus term, a minus in between, and it must be a minus, then it factors as a plus b and a minus b. So we're going to have the same 2 values, one with a plus, one with a minus. And the reason we have that plus or minus is because the only way you get a minus in a problem is if you have a positive and negative value that are multiplying together. Because otherwise, a negative times a negative is a positive times a positive is also a positive. So there's 2 conditions that have to be met. It must be a binomial, 2 terms. Those 2 terms must be perfect squares with a minus sign in between. And then you can factor them. So what you're really thinking about when you're factoring them is what the square root of each of those terms are, because that's what a and b are. So I want 2 numbers that multiply to be 4 because when I FOIL them back, I should get a 4. Does anybody know what this would look like if you factor it in parentheses? Emma? Yeah, x plus 2, x minus 2. The square root of x squared is x, because x times x makes x squared. So there's the x's. The square root of 4 is 2. So a positive 2 and a negative 2 make a negative 4. And then if you did a quick check, again, you don't have to, but just to show you how this works. We have x squared minus 2x plus 2x and then minus 4. These 2 terms, because one's a positive and one's a negative, cancel. That's how you get terms to cancel, because you have one being a plus and one being a minus. So looking at the second one, we have x squared minus 36. So you need to think about the square root of 36. Maddie, what's the square root of 36? 6. So they would look like?
X plus 6, x minus 6.
Right. And if you'd rather have x minus 6 in the front, x plus 6 in the back, that's fine. Same difference. And then x squared minus 64. Rebecca, what do you have for x squared minus 64?
X plus 8, x minus 8.
So that's factoring binomial perfect squares. There is one other special pattern, and that special pattern is with trinomial perfect squares. So now there are 3 terms. That last one is the perfect square. This pattern says a squared plus 2ab plus b squared. That means the middle number is 2 times the square root of the last number. So the square root of 9 is 3. 2 times 3 is how we get 6. The square root of 25 is 5. 2 times 5 is how we get 10. So if it's a plus sign, when you factor it, you're going to have a quantity squared. So a plus b, and then in parentheses with the square outside. When it's a minus sign, we'll have that quantity with a minus, and then the square outside. So this works when the last term is a perfect square, and the middle number is 2 times that perfect square. And again, we foiled this pattern at the beginning of class. So this one's a little trickier. Some of you might not want to use this, and you might just use the traditional factoring where you're looking at the 9. But if you notice that you have a 9 and that the middle number is 2 times the square root of it, then it fits into the perfect pattern, or the perfect square pattern. And the way you factor it is by taking the square root of x squared, so that's just an x. The square root of 9 is a 3. That middle number is created after we FOIL it. So if I checked my work, I'll just check it down here. Since it's squared, it means there are 2 of them. That's what anything squared is. And when you FOIL 2 of them, you get x squared, 3x, and 3x. There's that doubled piece. There are 2 of them. That's how I get the 6x. And then plus 9. So this pattern is more like, if you notice it's a perfect square, you might remember, hey, there's a pattern that goes along with it. Sometimes you don't think of it. So the next one, we have x squared plus 10x plus 25. This would just be x plus 5. So whatever this sign is in the middle has to be the sign that's in the middle of your parentheses. Underneath, we have x squared minus 6x plus 9. So because it's a minus sign, it gets a minus in the factor problem. And here would be x minus 5 squared. So I believe there are 3 problems at the top of the next page. I don't think I could squeeze them on the bottom. Oh, maybe only 2? Nope, 5. 5 problems at the top of the page. See if you can just factor those 5 problems. So the first 2 are telling you they're special patterns. So it's just you kind of matching what you're given with the pattern. And then the last 3, it's just kind of a mix of the types of factoring that we looked at. And you might want to use that page, the previous page, for homework, especially with the special patterns. Like, keep that page open while you're doing your homework, just to kind of see. It has all 3 types of factoring that we went over today, so it's a good page to use as a reference. Julian, how would you factor A? Right, so when it's a binomial, 2 terms get 2 factors because you have to have a plus and a minus. So binomial, 2 terms, makes 2 factors. Like Julian, letter B is just
m minus 11 squared.
right, m minus 11 squared. A trinomial is just 1 factor with that quantity squared. And then looking at the last 3, see if you can kind of work on those last 3. Your homework is in the book today, and it's just the factoring problems that we were working on. So it's 3 through 23, all of them. So I think it's 21 problems. Anybody interested in doing 14 or 20? Emma, 14, and Rebecca, about 20. So making sure you have these, you should have a +3 and a +4. For number 2, you should have a +9 and a -9. And the last one, a -6 and a -1. Let's make sure you have those correct. X + 3, X + 4. Or flipped, x plus 4, x plus 3. X plus 9, x minus 9. And then the last one, negative 6 and negative 1 multiply to be positive 6, but add to be negative 7.